Okay, this is the 3.7 extra example video. So we're doing operations of functions. I'm going to do one or two of the addition, subtraction, actually just one, and multiplication and division. And then we'll work on some more composition functions. For this first one, we're supposed to add the functions together, subtract, multiply, and then divide, and then we're also supposed to evaluate them at the value 3. So let's first of all just figure out what each of these would look like. If you do the addition of the two functions, that would just be negative x squared plus 2x minus 1. The subtraction, you need to be a little bit more careful. And remember that you are subtracting the second function, which means you need to think about it in a parentheses. So that would be negative x squared minus 2x plus 1. When you times, you'll be multiplying or distributing. So that would be negative 2x cubed plus x squared. And then in division, we stack it as one on top of the other. So negative x squared over 2x minus 1. Now we're going to evaluate each of these at the value 3. And since these are both polynomials, the adding, subtracting, and multiplying will all be all real numbers. The only problem that comes in with division is positive 1/2, because you have to think about this not being 0, and that's not 3, so we're okay. So this would be negative 3 squared plus 2 times 3 minus 1. That is negative 9 plus 6 minus 1, or a total of negative 4. For the next one, f minus g of 3, we would have negative 3 squared minus 2 times 3 plus 1, negative 9 minus 6 plus 1. That would be negative 14. For the f times g of 3, we would be doing negative 2 times negative 3 cubed plus positive 3 plus positive 3 squared. So this would be 3 cubed is 27, times it by negative 2, that would be negative 54 plus 9. So that would be negative 45. And then for the last one, f over g of 3, we would get negative 3 squared over 2 times 3 minus 1. That is negative 9 over 6 minus 1, which would be 5. So negative 9/5. For this next one, this is just, I know we did B and C for sure. I might have done this one in one of the classes, but I did not do it in both, so I'm going to go ahead. When you're adding, subtracting, multiplying, and dividing, you need to do those functions using those operations. So if I add the two functions together, you think of it as the first function plus the second function. Any like terms can be combined, so this would be 2x squared plus x minus 3. So there would be the addition. F subtract g, we take the two functions and we subtract, it's plus x. So the x squareds would actually cancel because this would become a negative x squared and a plus 3. So no x squareds, but we would have an x and a plus 3. F times g of x would be x squared plus x times x squared minus 3. That would be x to the 4th minus 3x squared plus x cubed minus 3x. If we write that in descending order, that'd be x to the 4th plus x to the 3rd minus 3x squared minus 3x. And then f over g, you put the first function over the second one, and just make sure it doesn't reduce. I could pull an x out of the top here, but it will not help me cancel anything. So the big thing is the domain of these. For the first three, the domain is always the same. It's what do these two domains have in common? Well, they're both polynomials, which means they both have domains of any real number. So for these right here, the first three, the domain would still be all real numbers. The problem with the division one is that now this is in a denominator, so it can't equal 0. So we have to take the square root of x squared, and we have to remember that creates a plus or minus. So this one would be all reals except plus or minus square root of 3. We did B and C in class over 2 days. So now we're going to scroll down and look at the composition of functions. We did 3 in class, so now I'm looking at example 4. There were parts to this one and we skipped over it. So f of g, remember me to do f with the g function plugged in. So we're going to think of that, I'm going to think of that in red, essentially. So the f is my outer shell. So I write 5, anywhere there's an x, I put a blank, minus 7. And in this blank, we're going to put the g of x function, which is 3x squared minus x plus 2. I didn't give myself much room. I would then distribute the 5, so that'd be 15x squared minus 5x plus 10 minus 7, and combine any like terms. So this would be f of g of x. So that's A part. For B part, we're doing g of f of x. So I'm going to do that guy where he's in blue. G is the outside function this time, so 3 blank squared minus blank plus 2. Inside those blanks, you put your f of x, which is 5x minus 7. This one will be a little bit harder to work out because we'll have to square this. So this would be 3, and that would be, let's see, I'm going to do this in my head, so I don't have enough room to write. So that would be 25x squared. You'll get 2 negative 35x's, so that would be negative 70x. And negative 7 times negative 7 is positive 49. Go ahead and distribute this negative, so that'd be negative 5x plus 7 plus 2. We need to distribute this 3, so that's 75x squared minus 210x, and that would be 7, carry the 2, 12, 13, 14, plus 147. Let me double check that real quick. Yes, and then bring down everything else. Combine like terms, so we have a 75 x squared minus 215x, and then this would be 9, or actually I'm going to make this will be 154 plus 2 more, so 156. So this one was obviously harder to work out. When you're doing the C and the D, the better way to think of it is to just do it one piece at a time. So I'm actually going to create some space so that I can do this. So f of g of negative 2. First of all, you have to plug g, well, you need to do g of negative 2. So g of negative 2 is using the g function. We do g of negative 2 equals 3 times negative 2 squared minus negative 2 plus 2. That would be a 4 times a 3, so that's 12, plus 2 plus 2, so that's 16. And then we do f of 16 into the f function, so that'd be 5 times 16 minus 7, which is 80 minus 7, or 73. To do this guy, we need to do f3 first. So g of f of 3. Go ahead and do my side work. So f of 3 is 5 times 3 minus 7. That would be 15 minus 7, or 8. So now I need to do g of 8, and that means plug it into the g function. So this would be 3 times 8 squared minus 8 plus 2. 8 squared is 64. 64 times 3 is 192. So this is 192 minus 8 plus 2. So that would be 184 plus 2 would be 186. So there are my 4 answers for this example. We want to do the same steps for B and then C. So f of g of x, we're going to find that first. That means write f as a shell, plug g into it. So that would be 3x and 3x. Work out the powers. So 3 cubed is 27, x cubed is x cubed, plus 2, 3 squared is 9, x squared is just x squared. This would be 27x cubed plus 18x squared. G of f of x. This time the outer shell is the g, so that would just be 3 and then blank. Inside the blank we put the f function, so that would be x cubed plus 2x squared. All we have to do is distribute the 3, so that would be 3x cubed plus 6x squared. Then we need to do f of g of negative 2. So we're going to do this part first. G of negative 2 is 3 times negative 2, which would be negative 6. So now I'm doing f of negative 6. So that would be negative 6 cubed plus 2 times negative 6 squared. That would be negative 216. That is 36 times 2, which is 72. So 72 minus 216 is negative 144. And then we need to do g of f of 3. So we're going to do this part first. So that would be 3 cubed plus 2 times 3 squared. That's 27 plus 2 times 9, which is 27 plus 18, which would be 45. So now I need to do g of 45. And g of 45 would be 3 times 45, which is 135. Okay? And then the last one in this section of notes is this guy. This one's a little interesting because we haven't had one where we've had a constant function yet, but this is actually pretty easy. If f is your outer shell, there's no x to plug in. Therefore, you can't plug the other function in. So it's just 5. G of f of x does work, though, because g is blank squared, because the x actually exists over here, and we plug the 5 in, but you still just get a number. So it would just be 25. And then f of g of negative 2 would be g of negative 2 means we plug in negative 2 to get squared. That makes it 4. The f of 4, but the thing is there's no x here, so it always reports itself as a 5. And then g of f of 3 would be f of 3 first, which is just 5, because it always reports as a 5. So then g of 5 is 5 squared, which is 25. So it's a lot less interesting when you have a constant function involved. Okay, from the last example, because I said example 6 you could omit, the last example in this section is just a bunch of f of g, g of f, and finding the domains. I did two, I think, in class. We did the radical one, and we did one with a fraction. I just want to go through and do some other variations of these. So we're going to look at the examples that we skipped over. So for B, first thing we want to do is f of g of x, which would be f is the outer shell, and g of x is getting plugged in. We would work this out. So this would be, squared is just going to cancel out, so that would be negative x plus 1. Then we need to do g of f of x. This time g is the empty shell, and we're going to plug f of x inside, which is negative x squared plus 1. And there's not much I can do with this, so I'm just going to leave it as is for right now. When we talk about the domain, though, we have to be careful. The domain of this guy originally is all real numbers, the domain of this one is, because it's under a square root, it has to be greater than or equal to 0. So it's 0 to infinity. When you do a domain of a composition, you care about the interior function and the end result. In this problem, the interior function was g of x, which means we have to deal with 0 to infinity. The end result is a polynomial, which means it's all real numbers. What those have in common is your overall domain, so it would be 0 to infinity. So that would be the domain of the first one. This one gets a little messier. The interior function is actually all real numbers because it's this guy over here, so that's the interior. The end, though, not so great. We now have a quadratic where you have a x squared inside, which means you can't just do this by setting it greater than or equal to 0. You can, but the problem is you now have to do the chart method. So I'm actually going to write it in descending order, and I factor this into a difference of two perfect squares. And remember, that gives us two critical values. This one will give us -1, and this one, if you solve it, would give you +1. And then we have to do a chart. -1, +1, close circles on both because of the equal to sign. We pick a test value on each side of those ratios, or those numbers, I should say. We plug it into a 1 plus x and a 1 minus x. Here, this gives me a negative and a negative, which gives me an overall, actually, no, sorry. 1 minus -2 would actually be a positive. So that actually gives me an overall sign that's a negative. 1 plus 0 is positive. 1 minus 0 is also positive, so that gives me an overall positive. 1 plus 2 is positive. 1 minus 2, though, is negative, which gives me an overall negative. We want to be greater than or equal to 0, so the only region that works is the one in the middle. So that means this guy has a domain of -1 to 1, and where they have a common domain, since this is the whole number line, it would just be this guy. So that is my common domain for my composition function. So these are two different problems. One case is f of g, the other is g of f. Let's do another radical one. Make some more room. Okay, first thing I'm going to do is find their individual domains. That seems to help me towards the end. So since these are both square roots, I'm going to set them greater than or equal to 0. This one you would subtract 3 over, but then you have to divide by a -1, so it makes it x is less than or equal to +3. X plus 2 is greater than or equal to 0 would solve as x is greater than or equal to -2. If we do f of g of x, f is the outer shell, so this would be square root of 3 minus blank. The interior would be g of x, which is another square root, so that would be square root of x plus 2. And then I can't really do anything with that. It's a radical inside a radical. It is what it is. And then for this guy, we would have g of f of x, which would be the g function is blank plus 2, and we're plugging in f of x, which is the square root of 3 minus x. And again, you can't do much with a radical inside a radical. So this would just be this. Now, in terms of domain, this gets really tricky. And in fact, I'm going to skip domain on these because we are not going to ask you to do that on the test, mainly because you have this radical inside of a radical situation. So I wouldn't stress about this. It's not going to be on the test in terms of the domain if this was a situation that popped up. So let's just focus on what we need to know right now. And then this one, we would do f of g of x, which is f is blank cubed plus 5, and the inside would be the g function, which would be cubed root of x minus 5. And I'll finish that in a minute, and then I want to do g of f of x. G is cubed root of blank minus 5, and we're plugging in the f, which is x cubed plus 5. You're going to notice something interesting happens with these two functions. This cancels out and leaves you with x minus 5, but you have the plus 5, so you just get x. And this guy, you would have the 5's cancel out first, so you just get the x cubed, and x cubed under a cubed root is just x. This is special. This is what we're going to learn about in section 5.1, which is the very first section in Unit 3. If this ever happens when you compose both ways, that means these two functions are inverses of each other. So that's going to be something we talk about a lot in the last unit. So this is just kind of a, oh, look, we saw that once before. So domain-wise, this isn't too bad because this is a polynomial, so it's all real numbers. Odd roots also have a domain of all real numbers. So the interior function for both of these is going to be all real numbers. The final result is also a polynomial, so that's all real numbers. Same thing here. Interior result is all real numbers. End result, all real numbers. So across the board, the domain for both of these situations is all real numbers. So cubed roots and cubes don't have any issues really. Okay, let's look at E, which has a fraction involved. So let's do f of g of x. We write the f function with the x missing. Inside that we place the g function, which is x minus 1. So this becomes then 1 over x minus 2. Let's go ahead and do the domain. This is all real numbers because it's a polynomial. This one, x cannot equal positive 1. The interior function counts for the domain. So the interior here is g of x. That's all real numbers. So that's interior. The end result also counts, and that would be x cannot be 2. So my final domain for this first one would be all real numbers except 2. So if you wanted to write that in interval notation, remember we use a union to jump over that 2 value, and the parentheses says that the 2 is not included. So these are parentheses, not brackets. And then we want to do g of f of x. So we write the g function as a shell, so blank minus 1. We're going to plug the f of x function in. And then we need to get a common denominator. So this would be 1 over x minus 1 minus 1 times x minus 1 on both top and bottom. So this would be 1 minus x plus 1 over x minus 1, which is negative x plus 2 over x minus 1. So that would be the function there. The domain, you have to look at the interior function, which had x cannot equal 1. That is still the domain at the end. So the overall domain is anything but 1, because it stayed the same domain issue in the interior function and in the end result. Okay, let's look at f. I'm going to move it down. Yeah, because this will be our last one on this video. So f of x, g of x, and then we'll also want to do g of f of x. Go ahead and talk about my domain. In this guy, you can't be 2. And since there's just an x in the bottom, that means you can't be 0. So f of g of x means write the f function with missing blanks for the x. And then the g function will get plugged in. So 3 over x, 3 over x. To simplify this, we would need to multiply everything on top and bottom by x's. So that would just give me a 3 on top and then a 3 minus 2x on bottom. So let's talk about the domain of this one. You have to look at the interior and the end when you're doing a composition. So this would be interior was g, so x can't be 0. This guy gives us a new problem, so we need to set that equal to 0 and see what the problem is. So it'd be positive 3/2. So remember, this guy would have a combined issue. It has to throw out both values. I could write that in interval notation, but I'm going to just go through this really quickly. So then this guy would be 3 over blank this time because we're trying to replace this x with f. And the f is x over x minus 2. You could think of this as 3 over 1 if you want. So this is 3 over 1 times x minus 2 over x if we multiply by the reciprocal. So this would be 3x minus 2 over x. So that would be the end result. So my interior function this time was f of x, which means x cannot equal 2. And the end result has an x in the bottom, which means x cannot equal 0. So my overall domain would be any x except for 0 or 2. And that is the end of this section.